Okay, I think it is visible now. So we are going to deal with a concept of functions. You know this concept or you have probably used, but I am going from scratch for every topic in C. That's why I'll go from scratch in this also. And probably you will find few new things which you are not knowing or which you are neglecting while using these functions in this discussion. Okay. So what is a function? We'll go for a simple analogy, what we use in day-to-day life. Every one of you have a bike or a two-wheeler, or you may have car at your places. Okay, so every one of you have a two-wheeler. You ride the two-wheeler, you use the two-wheeler, you purchase it from somewhere, and sometimes you need that vehicle to be serviced. Okay, in that case, what you do, you go to a you don't service it by yourself. You go to a mechanic, you give the vehicle to him. You don't know what he is doing on that, but you want a serviced vehicle. Okay, or you have some problem in your vehicle, in your bike. You are going to tell him that problem, and he's going to fix it up, and you want a repaired vehicle back to you. Okay, you don't know why, how he's doing it. You don't really bother how he is doing it. What you want is whatever thing you have given and whatever output you expect, the output should be given in that particular. Okay, so you go to a mechanic, you ask him that please get my bike serviced, and he'll call you after 2 3 hours or a day's time, and you go back, you'll collect your vehicle in a serviced condition. Okay, so there are three aspects in this. Here is you, the mechanic, and the bike. So you are taking help of a specialized person to service your bike, right? Mechanic is the second aspect, who is a specialized person or a person who is specialized for a particular task. He repetitively do that thing. Okay, he is dedicated for that purpose. You are seeking help of a mechanic for a purpose for which he is dedicated. Okay, so you are a service seeker and he is a service provider. You are trying to call a service from him, and he is going to accept and will provide a service to you. Okay, in this, third component is your two-wheeler or your vehicle or your bike. You, the calling person or the calling module, is giving that uh, bike to a mechanic. So, and that bike is getting processed, on which it is worked on, and the serviced bike, the processed bike, is given back to you. So, the calling module is giving the giving something to the called module. Called module is processing that thing and giving it back to the calling module. Okay, so here you are a calling module. You are taking help of a person who is specialized in that task. You also want, say, you also want your bike to be washed, and that mechanic doesn't have any setup for washing. What will happen now? He will take help of some person who has that setup or who is specialized in washing. Okay, he will send that bike to the washer. Washer will wash that bike, give it back to the mechanic, and mechanic is giving it back to the uh, giving it back to you. So how that bike is going? Bike is going from you to mechanic, from mechanic to washer, from washer to mechanic, mechanic to you. So you are calling a person, you are calling a module. That module is in turn calling another module. That another module is having its own task to be done. This module has its own task to be done. And who are you? You are just seeking the services from uh, the mechanic. You don't know where he is getting the vehicle washed. You want a washed vehicle and you ask the mechanic to do it. Is taking help of the washer. So what can I say is, uh, when I take this scenario, this analogy on the programming, you are a calling program. You are doing many tasks, out of which you want your vehicle to be serviced. So you are a calling program, you are seeking program, you are seeking function or calling function. You are calling the function mechanic. That and you are passing a parameter to that mechanic. Parameter is bike. You are giving a thing to a mechanic, that is a parameter. So a calling function is giving a parameter to a called function. Called function will process that parameter and will give it back to you. Or the calling function will provide a parameter to a uh, called function mechanic. Mechanic will process halfway through that, and then he will call another function washer, and that washer will finish that thing, finish washing, will give that parameter back to the mechanic. Mechanic will finish servicing and will give that parameter back to the calling program. That is it. Okay. So a function can call another function, which in turn can call another function, which in turn can uh, call another function. There can be nesting of functions together. Okay. So what is the function? Function is a block of statement that perform a specific task. For that matter, any program performs a specific task. Where if you remember the definition of C program uh, or C program, uh, what I said was it is going to have at least one function. And if it is only one function, it will be main. That means it can have more than one functions. Each function is going to perform its own task. But what is main? Main is the entry and exit point of the program. That is why a function is a block of statement that performs a specific task. A very large program is divided into small blocks called as functions. Very large program will be divided into small blocks called as function, and there will be a main function from which we are going to enter, and that main function is going to call other functions for a specific task. Okay. uh, so those are called as functions, and this feature of function only makes C a procedure oriented programming. The function contains a set of programming statements enclosed in the curly braces. Main also has its body mentioned in the curly braces. Similarly, every function is going to have those braces. Function can be called multiple times to provide reusability and modularity to the C program. The function can be called multiple times to provide reusability and modularity to the C program. Hence, we are dividing the whole program into small modules. We are dividing the whole program into small modules, and those modules can be reused number of times. Okay, like what I given an example is, okay, I will finish that and we'll come to this point later. In other words, we can say that the collection of functions create a program. Because there will be number of functions which will uh, create a program, or together those functions will build a program. And functions are also known as procedures or subroutines or methods in other programming languages. Why we need functions? Why we need functions? To improve readability of the code. Say if you are writing a huge program without any functions, in the main only you are writing all the tasks, maybe some tasks are repeated, you are writing the number of times, there will be a huge program written. So the readability of the program code will not be good. Uh, like you write a essay, but you don't write essay continuously, but you write it in paragraphs so that it can be read clearly. That's what we are doing here. Improves the reusability of the code. Yes, see, just now whatever analogy we have taken, you take your vehicle to the mechanic, and regularly you take your vehicle to that mechanic. You can take it 10 times every month, once in a week, once in a month, uh, once in a year. But every that mechanic, you can take your vehicle to that mechanic a number of times. You can seek the services a number of times. Okay. Or the mechanic is there, a garage is there, and many people can go to that garage and ask for the service of that mechanic. Or in other case, you have three vehicles: a bike you have, a moped you have, a scooter you have. You can take all these. Calling function is same, called function is same, but parameters are different. Once you have taken your bike, second time you have taken your moped, third time you have taken your uh, what you say, the scooter rate. So yes, so mechanic is there, and we are reusing his skills number of times. So similarly, a function can be written, and that function can be called a number of times by the same program, or same code can be copied in number of other codes instead of writing it right from the scratch. So that is what we are referring to, the reusability of the code. Same function can call that same calling function can call the function number of times, or that function can be written in number of programs uh, without rewriting it. The same code can be copied everywhere. So that increases the reusability of the code. Debugging will always be easy because exactly where the problem lies, in which function the problem lies, you can very easily trace. And it reduces definitely the size of code because duplication of code will be avoided. It can be replaced with a number of function calls. Fine. So this is what I request is, if you are having any doubts, keep on posting it in the chat box. I can address it uh, as and when the uh, doubts will arise. So right now I'll proceed, or if you have any doubts, you can just unmute your mic and tell me. Okay? If you have any doubts, you can unmute your mic and tell me, or you can put it in the chat box. I can solve the doubts. So it's okay. Now we'll proceed. This is the way a function can be defined. A general form of function definition. Function definition. This word, you be careful. Uh, so it has a function name of the function. You can see this example parallelly: int add, int x, int y. Okay, so add is the function name. Add is the function name. So this function name can be any name which can be formed with all the valid rules used for forming a variable name in C. So just like a variable name, I can define function name, any function name I can give. I can have a parameter list, the list of parameters, list of variables on which you want that special task to be done, for which the function is dedicated. Okay, so that is a parameter list. This is optional. You may pass a parameter or may not pass a parameter. Okay, uh, like you are giving your bike to the mechanic, so bike here is the parameter which can be changing. Next time you may give a moped, next time you may give a scooter rate. So the parameter list is optional in this case, but in this function parameter has to be there. You need to give something to the mechanic so that he can service. You need to give a cloth to a tailor so that he can stitch it. Okay, but if you are going to a ready-made shop, then you are not passing any parameter. You are not giving anything to them. Anything means, of course, you'll have to give money. But if you are not giving anything on which it need to be processed on, you get a ready-made clothes available with you. So parameter is an optional thing. You may or may not use it. But if you are using it, they will be placed in a bracket immediately after the function name and the return type. You have to mention a return type. A function has to return something, and if it is not returning anything, it has to be null. We need to specify the return type as void if it is not returning anything, or you have to specify a return type. Why this return type is that important, I'll come to the discussion in the next slide, why this is very important. And then we mention a body of a function. This function body can contain every possible statement, every possible valid statement which can be used in C. Right from the declaration, you can have a declaration in a function body, you can have printf scanf statements, you can have assignment statements, you can have if else statements, you can have all looping constructs, you can have a function call within a body also. So every valid statement of C can be accommodated in the function body. Ultimately, whatever program till now we have written, what we are doing, we are writing the function body of main. Similarly, you can write function body of all other functions. Okay, so this can have all the valid statement. I'll go for an example directly so that it will be, then we'll come back to these slides. Let us see this example. What will happen? Okay, it is adding two elements, but it is taking help of a function to write this. Okay, right now I am taking an example without any argument and without any return value. It is not having any argument and it is not having any return value. So include stdio.h is a normal functionality because we may be using printf and scanf in the program. So every time we write that. Then what I encounter is void sum is a something which is similar to a function. So this is your function declaration. It is just notifying the compiler that you may encounter a function called as name sum, which is taking no arguments and which is uh, returning no value. Which is returning no value. Okay. So there is a function in existence. This is the only information we have provided with this particular statement. Next is void main. Void main will always be there in any function, in any program, because your main is the entry and exit point of your program. You are going to enter to that program, and no matter you are writing hundreds of functions, main will be only one, and that will be the only entry and exit point of your program. Okay, the program will begin from main, and it may move from function to function, but it will come back to main and get terminated. Okay, so it will always be there. So main is the entry point, then it will print this statement. The statement is posted as it is. And what is next? Now be careful in listening to this. As soon as this statement is encountered, this is not a declaration, this is not an assignment statement, this is not a conditional statement, this is not a loop statement. But it will, because of these brackets, it can understand that it is a function call. Means the function main, the calling function main wants to take help of some function which will perform a specified task. I don't know what task is going to be performed, but right now I have encountered a function called as sum, which has no parameters. What compiler will do now? Compiler will, as soon as it encounters this, compiler, be careful in listening this. Compiler will check the code above that line. Will check the code above that line to confirm the existence of sum. To confirm the existence of sum. As we are declaring all the variables well in advance, and then later you can use that variables. Why doing it? Why we are doing it? Because that variable is uh, making sure that that variable is validly declared and allocated some space for it now. Here also we are doing the same thing. Sum is sum is verified. This occurrence of sum is verified. Existence of sum is verified, whether something exists or not. And it can find that yes, there is something declared called as sum, which is taking no parameters and is not returning any value. So this kind of declaration is in existence. That means sum is in existence. Existence of sum is verified, and now it can be used. What will happen now? After this function call, as soon as this function is called, the control control will pass to directly that function. This is a function call. At this particular moment, I want that task to be done. So I'm going to that task. Okay, the control is passed to sum. Two variables are declared. A, B, the printf statement is printed. Scanf statement is used. Let us say that A is 10 and B is 20. I am entering. See here, as I said, every valid statement of C can be used in the function body. So the function body of sum is having a declaration also, a printf scanf statement also, arithmetic statement also. Okay, so it is going to print the sum is 30. This is going to print sum is 30. The sum is 30. Okay, it is going to print that. Fine. Now what happens? So this statement is printed. Now there is a end of the function sum. End of the function sum. At the end of function sum, what will happen? The control will go back to the next statement to the function call. Okay, so it will go back to the next statement after sum. What is the next statement? End of main. Okay, now this function will be ended. This program will be ended. So remember well what's happening. As soon as we call a program, the cursor will immediately pass to that function. The functionality will be executed and it will come back to the place immediate next to the line immediate next to the function call. ओके, फंक्शन कॉल का इमीडिएट नेक्स्ट जो लाइन है उसके ऊपर वो आएगा ताकि द कॉलिंग फंक्शन कैन रिज्यूम इट्स एक्शंस. Calling function can resume its action. Okay, so this is the way a function is getting called. Again, I am repeating. If you have any doubts, you please post it or ask. Now coming back to the theoretical aspect of that, am I clear? Am I clear? I'll go for one more example so that doubt will be more clear. This is an example where I am not passing any arguments but try to return a value. Not passing any argument but try to return a value. Okay, arguments means parameters here. Arguments means parameters. So parameters are also called as arguments. Now stdio.h is included. Unlike previous one, what is the change here? You can observe. In the previous one, integer was a sum was returning nothing. It was void. In this case, sum is returning an integer value. Yes, this is the return type. If sum is not taking any parameters, but it is going to return an integer value. Okay. So if it is returning, I need to have something to collect. I need to have something to collect. Something means exactly of the same form. So if it is returning an integer, I need to have an integer to collect. If it is returning float, I need to have a float element to collect. How it is done, that we'll see now. What's happening here? So int sum is defined, void main, the start of program, and integer result is declared. A variable result is declared. I'll just write R here. Variable result is declared. Then a printf statement. So this variable will be printed on a similar way. Let us say that R is located as location 1000. This statement will be printed as it is. Now what's happening? This statement is unlike previous one. Unlike previous one, in previous one we had only this part. This later part is added over here. Why? Because sum is a function which is returning an integer. तो उस इंटीजर को कलेक्ट करने के लिए मेरे पास एक कंटेनर चाहिए. उस कंटेनर का नाम है रिजल्ट. ओके, सो इन रिजल्ट इट इज गेटिंग प्रिंटेड, sorry, it is getting stored. So whatever will be returned by sum will be stored in result. So it is a function call. It will confirm that yes, There is a function call has no parameters, has the same name as that of sum, and has a return type integer which is collected in another integer variable. That also it makes sure. If you don't collect it, it is going to give you an error. It is going to produce an error. So it is returning something. You need to collect it. Okay, that is very important. So as soon as this function is called, your control will pass through will be moved from this position to this position. Right now, this result is not into picture. Sum is called. This will come here. A and B, integer two numbers, add two numbers. Let us say that 10 is added, 20 is added. Okay, here you can see that our previous case also A and B are members of function sum. They are not members of main. Main cannot access A and B. Main cannot access A and B because they are local to sum. Okay, they are local to sum. So A and B are collected, say let us say that 10 and 20, and then what we are doing, unlike previous one, in previous one what we did, we stored that value here only. We stored that value, or sorry, calculated this value here only within the function. Here we are not doing, we are we are doing the same, but we are doing it little differently, where we are sending the total value back to the calling function. So here what we are seeing, return a plus b. So this function is going to return 30. This 30 will be, uh, it is going to return 30. It will come here. It will come here, and it will just see result is equal to 30. Okay, result is equal to 30 because 30 is a variable which is collecting the value returned by sum. Okay, it is collecting the value returned by sum. So result is 30. Result will hold the value 30. When I print it, it is going to print 30. Okay, so this is what I'm saying, that the way of returning a it is returning a variable. Now coming back to this, coming to some theoretical aspect of your, I think you are not raising any doubts. Are you understanding or not? I still have a question. I'm just assuming that you are understanding. So if you still have any doubts, or at least prompt yes in the chat box so that I can proceed. Baby is saying yes. So I expect that you are understanding. Now we'll just have some theoretical aspects of it that we'll have to remember. Function definition in C programming consists of function header and a function body. Okay, there are four aspects which we have in this. One is the return type. Now, uh, what the function may return a value. Function may or may not return a value, but function need to return the control. Function need to return the control back to the calling function. Okay. So as soon as the function is called, the control from calling function is moved to the called function, and this called function, this called function performs the task and give the control back to your calling function. So but when it give the control back to the calling function, it may give it with a value or without a value. Okay, so if it is returning some value, then we need to mention the return type. But if it is not returning any value, uh, we can mention void. you can mention void. So yeah, so function will always have a return type, and if it is not returning in value, it is going to be uh, void. Okay. Now function name, the function name and the parameter list are the two important aspects, because with that name, that is the actual name given to a function, with that name only the function will be recognized and function will be called by any of the calling function. And along with that, we must have a parameter list. It is optional, but if you have a parameter list, then together they form a function signature. Together they are called as function signature. Parameters are, again I am repeating, they are optional, but they are, if they exist, they are the placeholder. Means if I am passing two integers, like if I am passing two integers, there will be two integer variables in the parameter list. So just now I said when a function is going to return a value, you need something to collect it. Similarly, when a calling function is passing some variable, if you are giving some variable to the function, it also need to have something to collect them. So if you are passing an integer, it must have a dedicated integer to collect it. If you have passing a float, it must have a float to collect it. Okay. So a parameter is like a placeholder. When a function is invoked, you pass a value to a parameter, and this value is referred to as the actual parameter of the argument. Okay. The parameter type will parameter list will refer to the type, the order, and the number of parameters of a function. Okay. But again, they are optional. The function may not contain any parameters. And function body, it is a collection of statements. It's collection of valid C statements, which will definitely define what the function is going to do, or what task the function performs. There are three things which you need to remember when you declare a pointer, sorry, function, use a function. One is the function declaration. A function must be declared globally in a C program to tell the compiler about function name, function parameters, and return. It must be declared globally, because if the function is used anywhere, the compiler must be aware that such type of function is available. Like in this program, we are this function is written here, but we are writing this part here. We are writing this part here, so that I'll just erase it. So I'm writing only minimum information, because this is called before the body. This is called before the body, and C says that you declare everything well in advance in C, because it should know what variables are declared and what are their types. So similarly, the function is made global, is declared before main, and specifically when we declare it before main, minimum things which you need to mention are the return types, the function name, and the parameter list. You can have the whole block, whole this block over here before main. Okay, you can have this. That is not issue. That is not an issue. So you can have that. Then you don't declare it twice. You declare only once. So this is function declaration, and this is function definition. That you remember. This is function definition. This is function definition. So there are two things which you need to keep: function declaration, function definition. Then there is a function call. Function can be called from anywhere in the program. Anywhere in the program. Okay, from any other function also. Not only by main, by any function. Only thing we need to keep in mind is the name of the function, the function parameter list, and the function return time should not mix match. Okay, should not mix match. So parameter list must not differ in function calling and function declaration. So the way we are calling, say we are having one integer, one float, and one character to be passed, it should appear in the same order in the calling of the function. First integer, then float, and then a character. Otherwise, it will not match up properly. we must pass the same number of functions as it is declared in the function declaration. Okay, if you are, even if you are declaring 5 elements, only 5 elements need to be passed to that. Okay, and function definition, it contains the actual statement are to be executed. It is the most important aspect to which the control comes when the function is called. As soon as the function is called and function gets over, the control comes back to the calling function, but as soon as the function is called, it will be sent to the function definition. Here we must notice that is one value can be returned from a function. Only one value can be returned from a function. That also included. So these are the two theoretical things, but I want you to remember them because you need to take care that you are doing in the same fashion as instructed, because so that you will be getting the proper outputs. Okay. So these two programs you have seen are without argument and without a return value, and without argument and with a return value. So here you can see that as soon as the sum execution is over, it immediately will pass the control to this. Or here also it is happening the same thing. It is passing control back to the main, and no matter the other statements whatever are coming are to appear or not. We'll tomorrow we'll have few more programs and example on functions in C. I hope I could make the points clear. We'll have few practices and uh, I also expect that you will start learning dynamic memory allocation by yourself. We'll have a small quiz on that. So that will be a self-study material. Or meanwhile, if any one of you think that they can deliver a good seminar on that, that will always be welcome. So this is all from my side in today's lecture. You may leave if you have no doubts. Okay. You may have, if you have doubts, you can stay back and ask it. Otherwise, you may leave. Thank you very much.